All right. I shouldn't have used pen because I screwed up and then had to start this one over. All right, so this is number 6, and it's talking about stuff that causes bell pepper plants to die. But instead of doing all of this data, it's just too time consuming without technology. I just circled these 12 numbers, and we're going to be asked to find the interquartile range and make a box and whisker plot. So the first thing you want to do with the data list is put them in order. When you guys take your exam, it will be, a small list like this. It's not going to be a giant list like this. So I put my numbers in order, and we're asked to find the interquartile range, but before you do that, you need to start with the median. Remember, the median is the middle. Since we have a list of 12 numbers, we would go halfway in between these two. So the median is going to be 13. The Q1 would be the middle of these 6 numbers. So Q1 is going to be 9.5. And then the Q3 is going to be in between these numbers. So the interquartile range is kind of like it sounds. It's the range of the quartiles. So it's basically how far apart are your quartiles. So it's Q3 minus Q1, which is 14.5 minus 9.5, which is an answer of 5. So your interquartile range is 5. When you make a box and whisker plot, the main thing kids forget and lose a point on is they forget a scale. So our lowest number is 9 and our highest number is 15. I mean, I'm just going to write all those numbers because that's not going to take me very long to do that. You can skip by 2s or by 5s depending on what your numbers are. And also, you always want to write a key. So this data is the soil water content, percent of water. So I'm just going to write percent water. Okay, so don't forget you need the first and the last, and you just put a dot. Don't draw any lines yet. You want both quartiles, so 9.5 and 14.5, and you want the median. Once you have your 5 dots, draw a rectangle to the quartiles, a line at the median, and then these are sometimes called whiskers. And you're done. Okay, the 5 number summary is just the 5 values that make up a box plot. So it's the minimum, the Q1, the median, the Q3, and the maximum. And you don't really need to memorize that. I mean, you guys are going to use notes. You don't have to memorize anything. All right, we're going to talk about what are some things we can do to deal with how spread apart data is. We could talk about the range, the interquartile range, which you can abbreviate like that, or the standard deviation. Those are all things that deal with how spread apart data is, and where the center is usually more focused on the median or the mean. So those are just some things to think about. Number 10 is just some notations. So if A means that you own a cell phone and B means you own a laptop, that little C just means the opposite of owns a cell phone. So this means does not own a cell phone. Okay? A and B, it means you own both. A or B, this one's tricky because it means you could own a phone, or you could own a computer, or you could own both. Both is included in an or. This line means given that A given B, that would mean they own a phone given that they own a laptop. And the vice versa, they own a laptop given that they own a cell phone. So that line means given that. Okay, let's do some basic probability. Let's say these are some marbles. We have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 marbles. I don't know if you can see these colors very well. These 3 are orange, these 4 are pink, and these 2 are blue. So we usually use addition and probability when we have the word or. We use multiplication when we see the word and then conditional probability is when you have to adjust your second fraction based on a condition. And I'm going to give you an example of each right here. So what's the probability? I'm picking a marble and it's either blue or orange. It's like you win if it's blue or orange. Does that make sense that all of these 5 marbles are blue or orange? Like you add the 2 and the 3. So I would just go ahead and write 5 out of 9. It doesn't mean you're picking out 2 marbles. This one doesn't. This one does mean you're picking out 2 marbles. What's the probability I pick out a blue, I replace it, and I pick a pink? So let's say I get a blue marble from the bag, would be 2/9. And then I look at that marble, but I put it back in, so there's still 9 marbles. And what's the probability we get a pink? There's 4 pinks. And then it's like both of these things are happening, like you get a blue and a pink. So we would multiply. I know this is basic and going back to elementary, but remember you multiply the top numbers, 2 times 4 is 8, and you multiply the bottom numbers in fractions. 9 times 9 is 81. That's our answer. This would be a conditional probability. What's the probability we get a blue marble and then I don't replace it and then I get a blue again? Okay, so the probability you get a blue marble to start is 2/9. And let's say I pick this blue marble, so it's not in the bag anymore. Now it's the probability to get a blue. Now it's just 1 out of 8. And we're going to multiply and we're going to have 2 out of 72. You can reduce that if you want. 1 out of 36. All right, you can ignore question 13. Question 14 deals with people with poison ivy, whether they had no reaction, a mild reaction, or a strong reaction of poison ivy based on if it was within 5 minutes or if it was after 5 minutes. So all your data is right here, and then I tried to make this solid line with a different pen, and these numbers out here are your totals. So they have some letters so that we don't have to keep writing all these words. A capital W means that they wash the oil off within 5 minutes. So this is our W. A means that it was after 5 minutes. M is our mild reaction. N is they had no reaction at all. S is a strong reaction. So find the following probabilities and out of these 100 people. So question A, what's the probability that N, meaning they did not have a reaction? We don't care if they washed off or not. What's the probability that they did not have a reaction? So that would be the total, 470 out of 1,000. I know we can reduce these, but I'm just going to leave these as fractions, like they are right now, so you can look back and see where these numbers came from. Okay, here's that given that. And on the exam, I will spell that out. I would say probability of strong, given that they washed it off within 5 minutes. Okay, so the given that becomes your denominator. So how many people washed off within 5 minutes? Washed off within 5 minutes, like washed off right away, are all of these people. That's 500 people. That's your denominator. Of these people that washed it off, how many of them had a strong reaction? Only 20. So that's our answer. Okay, what's the probability that a strong reaction given that they were an A? So now your denominator is still 500, but it's because it's the total of the afters. And how many of these people had a strong reaction? 120. So it sure seems like if they waited to wash out the poison ivy, they're more likely to have a reaction. Okay, here's the word and. So look in the chart. Who had no reaction and washed it off right away? No reaction and they washed it off right away. That's these people. It doesn't have a given that, so you assume that it's this number out of the total. So 420 out of 1,000. And finally, here's an or. These are the hardest. What's the probability that they had no reaction or a mild reaction? So this one's not that hard. It's everybody who had no reaction or a mild reaction. So it'd be all these people right here. So how many? Let's have 1,000, and that would add up to 860 out of 1,000. Okay, I'm going to add another one with an or. So probability that they had no reaction, or they were a group of people who washed it off after. So the reason this one's more difficult is because we have like these 50 people that are a none and an A. You don't want to double count them. So you want to count everybody who had no reaction and everybody who was after 5 minutes. It's like we want to count all of these people, but you don't want to count these 50 people twice. So oops, I didn't mean to have that 500. So we would have these, basically how I would do it is I know this adds up to 500, plus I want these people too. So 500 plus another 420 is going to be 920 over 1,000. Okay, number 16. I'm just going to skip ahead to the question. Determine total number of different ways. So we're not even looking for a fraction or probability. We're looking for a total number. In the Cash Now Lottery, there's 10 finalists, and they submitted entry tickets on time. From these 10, we're going to have 3 grand prize winners will be drawn. The first prize is $1 million. The second is $100,000. The third prize is $10,000. Why do they tell you all that? It's showing you that order is important. You would rather be the first prize than the third prize. I mean, we'd be happy with all of them, but order is important. Okay, and we're talking from 10 finalists, and we're going to choose 3 winners. Since order is important, the word important has a P in it, so use the 10P3. And you can type that in on your calculator, but for right now, it's a permutation, 10P3, and we would get the answer to that. Okay, number 17. A professor grades homework by randomly choosing 5 out of 12 homework problems. How many different groups of 5 problems could be chosen? Now it doesn't matter what order. It's just he's going to pick 5 problems from your 12 to grade. So if order is not important, you use C. So 12C5. And I'm going to have to remember how to find this too on my calculator. You do 12 and then math, probability, I think. Yep. And then C2 is the permutation and 3 is combination. I'm going to do C, and it automatically does the 12C, and then 5, 792. So what's the probability if Jerry only did 5 problems that the professor picked the exact same problems that he did? Not very likely, right? It's only one of those options out of 792 that Jerry's going to get a good grade on this. All right. So